Hi everyone, in this video you are going to learn the evolution of programming languages and the various programming paradigms used for producing reliable softwares. Apart from the programming knowledge, a programmer must know the various problem solving skills fitted for a particular domain. After viewing the video, you will aware about the current paradigms, particularly the most powerful paradigms called object-oriented paradigms, methods, approaches used for producing effective programming. Programming paradigms is the first topic that comes under the unit 1 of programming in Java paper. So under that you are going to learn the evolution of programming languages, generation of programming languages and various paradigms used under the programming principles. So we'll say one by one. First we will discuss the evolution of programming languages. You all know well that the field of computers is having two broader areas, hardware and software. The hardware is a field having devices like processors, memory, I/O and other subcomponents that are connected with computers. The field of software is dealing programming principles, languages, methods and approaches used for effective software development. Then we have to consider the field of hardware. Even the emergence of new devices under hardware. New devices are fabricated, manufactured based on the needs. Then we have to consider the field of hardware, we have to consider the structure of a computer. The structure of a computer is having three units, three functional units, input devices, central processing unit and output devices. This structure will remain same, even the shape will vary. For example, you consider a desktop computer with a laptop. Even you take the mini computers. So whatever the shape of the computer is, whatever the type of the computer is, always there is an input unit, processing unit and output unit. So the structure will remain same, that will never change. Only the shape will vary. Only the shapes and the processing speeds, processing terminologies will only change. But within the field of software, the programming languages and tools are introduced at a frequent intervals, even within a shorter period of timing. For example, you started to learn a language for programming. Before going to complete, there is an emergence of new language. So why such evolutions are there? Why software are introduced at frequent intervals? Why a software is not having longer lifetime? We have to answer. Stages of software development, it only involved writing of programs. Moreover, the programs were written for solving problems in the area of science, technology and business. Today we have to consider the field of computers. There could be a heavy demand for the computers to solve problems with more challenges and complexities today. Moreover, computers today involves more interfaces along with standard input devices, standard computing devices. Computers started to interact with the external world for communications. Automatically started to communicate. Automatically they started to talk with users. Even they are guiding the users to do some works. Not only the processing, not only the arithmetic calculations. Even computers predicts the future based on the user inputs. Computers are helping the users to make decisions for a business. So you have to consider the problems, the field of problems used for doing this. Under that, the hardware part is only used for getting inputs, processing the data and producing the output. So here there is no more contribution for the hardware side. But as a software, it has to analyze the input and it has to process the data and it has to prepare the result in the expected format. So these are all the reasons for the emergence of softwares within a shorter period. The problem areas are broader one. The problem domain are increasing. So the field of software development is also going on. That will never end. So most of the software today are having limited lifetime. As an approximate, a software is having a lifetime of minimum of 5 years to 10 years. So the creation of a software is not only involving writing up sequence of statements and doing some technical bunches like conditional checking, file manipulation, and database management. Apart from that, the programmers, software developers must know what are all the different programming paradigms, methodologies, and approaches used for developing effective softwares. Even the programmers must know this before going to write a single piece of code, and before going to sit on the computer, and before going to enter the statements on computers. So under this, first we have to discuss the generation of programming languages. Like computer generations, programming languages are also having their own generations. So see on the figure, the generation is classified as a layered stack. So under the bottom layer, the hardware is there. The machine part, that means the devices on the computers are there. Above that, the field of software is starting. So above the hardware, there is a word, machine language, assembly language, high-level language, and some languages, high-level languages like Fortran, C, Pascal, and the above in the top level, OO and visual languages are there. So what these are all? So these are all the languages introduced under each generation of programming languages. The languages developed on each generation is having their own scope and features, and the developed programming languages removes the problems. They removed the problems in the early stages. Even the programming languages developed on each generation are broadly classified into two categories: low-level languages. So under that, low-level languages and high-level languages. Under the low-level languages, machine language and assembly languages are classified. Machine language and assembly languages are closer to the specific machine architectures, and the high-level languages are closer to the human languages. Moreover, the high-level languages are focusing on specific problem domains. Some of the examples of high-level languages are BASIC, Fortran, COBOL, C, and C++. First, we'll discuss the first generation languages. In short, they are called as 1GL. So, under the first generation of computers, and even in the first generation of languages, machine language programming (MLP) was used for doing programs. Under MLP, programmers converted the logic into direct binary code. So under this, there is no software paradigms used. There is no software process used. Suppose a programmer wanted to program for a problem, the programmer has to first form the logic, and thereafter the programmer has to convert each logic, that means each statement, into direct binary code. The computers used on the first generation, like Analytical Engine and ENIAC, that computers were used machine language programs. When the first programmer, lady programmer, Madam Ada Lovelace, wrote the first program by using punched code for Analytical Engine, and the programmers of ENIAC used a panel of toggle switches to enter the binary signals. The entered signals were taken by the sequence of wires into ENIAC for further processing. Actually, the Madam Ada Lovelace created a logic for making holes on the punched code, and that whole punched code were taken by the Analytical Engine for further processing. So see the diagrams. So in the left side, the logic wrote by the Ada Lovelace is there. Actually, the information is put as a table. The programmers had to take the informations, and based on that information given on the table, they have to produce holes on the punched card, and they have to fed on that actually Analytical Engine. Actually, they have to fed that punched card, deck of punched cards over the Analytical Engine. The Analytical Engine started to process, and it produces a result as a holes, punched holes. Actually, then you see the right side image. There are two engineers were toggling the switches by doing switch oning some sequence of switches and switch offing some sequence of switches. So in such a way, the computers were operated. Next, we will discuss the disadvantage of machine language programming. For machine language programming, that comes under first GL. All logic were directly converted into binary signals before going to be entered on machines. It's very difficult to find the errors during the execution. Then, no memory was used and there might be a power failure. The program is to be entered again from the scratch. Moreover, it takes a longer time to convert the logic into signals and enter the signals into the machine. So, these are all the main drawbacks of machine language programming. Programmers felt very difficult to understand what the logic is there and how to convert the logic into a direct binary code. The important problem under the machine language programming is there is no software process. Even there is no software used on first generation of languages. In the first generation, the second generation of languages were introduced. Under second generation, assembly language programming ALP was developed. Actually, the assembly language programming removed the problem of direct binary coding, direct binary programming. In assembly language programming, programmers used a simple keywords called as mnemonics. Examples of some mnemonics are add, sub, mul, stay, means store, end. As a sample, the assembly language program is something good like this: add a, b, move c, end. So under the assembly language programming, assemblers are acted as the translators to convert assembly language program into direct binary code. So now the assemblers did the concept of direct binary code conversion. So ALP was mainly used in the second generation of computers. That means assembly language programming was mainly used in the second generation of computers. Under second generation of computers, we all know well, transistors and microchips were introduced. The main advantage of assembly language programming is they removed the problems in machine language programming. It's very easy for the programmers to write their logic. Assemblers, as a translator, the assemblers did care of the logic to binary code conversion. There are also disadvantages under assembly language programming. The main disadvantage of assembly language programming is that it's processor dependent. For example, an assembly language program written on one machine could only run on that other machines which are also having the same processors. For example, there is a microprocessor we all know well, Intel 8086. Suppose an assembly language program is designed for that 8086 and that program is only running on machines which are also having 8086. Suppose there are other processors than 8086, the ALP is not running on that machines. One more problem faces under assembly language program. The programmers, the persons, ones who know the assembly language program well, they only could understand the flow of assembly language programming. So that the readability of the assembly language programming is also very poor.